Hey everyone, welcome to TitanClass. On this episode of TitanClass, we're going to talk about a whole bunch of pre-calculus stuff. Part 1, coterminal angles. Part 2, degrees to radian conversions and backwards. Reference angles, exact values of trigonometric functions, and finding all trig ratios when you're given either a theta measurement or another trig ratio. It's going to be a jam-packed day. Let's get it started. All right, part 1, coterminal angles. The thing about coterminal angles is really in the name, coterminal. So coterminal means the same end, the same ending point, right? So when I have a coterminal angle, it just means wherever that angle lands on the unit circle, I'm finding another angle that lands on that same spot. And we're going to do that by using one more full revolution positive or one revolution negative. So let's get right into it. Oh, and by the way, did I mention I've got 50 problems for you? It's kind of the way things work here at TitanClass. Let's go. Number 1, if I have a 195-degree angle, this section is going to represent both a positive and a negative coterminal angle to what I'm given. So I'm going to have to get two answers here. Well, when I have degrees, which is this first set, very easy to do. 195 degrees is within one full revolution of my circle. Now, on the coterminal world, usually we won't have to graph these things because making our circles around and around and around can get a little tedious. So in this particular case, if I want a positive coterminal angle, I'm going to add one full revolution to this measurement. So what I'm doing is I'm going to add 360 to this measurement of 195. That's going to give me another angle measurement that is coterminal, meaning it will end at the same place as 195. So when I add these together, I'm going to get 555 degrees. That is the positive or a positive coterminal angle to 195. Now, if that worked out for the positive side, let's go back to our 195. That's a 6. I said 195, and I wrote a 6. Interesting. If I want a negative coterminal angle, well, I'm just going to subtract 360, meaning I would take this angle measurement and just go from that way the other way around, right? So I'm going to subtract one full revolution from there, minus 360, and that is going to give me a negative 165. Now, one thing to remember about coterminal angles, 195 was the initial OG terminal end. 555 degrees and negative 165 degrees represent one more revolution around that will end at the same spot counterclockwise, and the negative 165 represents one full revolution clockwise, and it still ends at the same spot. So number 1, our answer is 555 degrees and negative 165 degrees. Okay? So the rest of the problems in this set are going to look very similar. Number 2, 30 degrees. All right, well, that's not too bad. I'm going to add 360 to this, which is going to give me a 390-degree angle. That's the positive one. And then I'll take that 30 and subtract 360 from it, which is going to give me negative 330 degrees, which is the negative coterminal angle. One thing to note as I'm putting the answer here for number 2 is there are an infinite amount of coterminal angles. Remember that the unit circle is a circle, right? And circles in general, they're circles. That's why they're named that way. I can continue to go around and around and around that circle. There is no beginning and there is no end of a circle, right? So just something to keep in mind whenever you're on Jeopardy. You can answer that question. Number 3, 435 degrees. This one's going to be a little bit tricky. If I want a positive coterminal angle, I can certainly add 360 to this. But take a look at this angle in general. This is already more than one full revolution around that circle. What that is going to do is if I just add 360 to it, it's going to make a bigger number, which is an answer. There's no doubt about that. but we can subtract 360 from this, right? And if I subtract 360 from that, I'm still in the positive realm. That's a 75-degree angle. That is also a positive coterminal angle. So 75 degrees is a viable answer. Now, I could have added 360 to 435 and gotten, I don't know, 795. Yes, and that is a positive coterminal angle. Either one's fine. Anything you do on a piece of paper, though, in terms of something created by a computer, it's going to have 75 as your answer choice over your 795-degree angle. Now, the negative one, if I go back to my 435, well, in the other two problems, I was just able to subtract 360, but that still yields me 75. I have to subtract 360 again, meaning I'm going 2 full revolutions clockwise to get to my negative coterminal. And the reason is because I was already over 1 full revolution, right? So 75 minus 360 is going to give me negative 285 degrees. So our positive coterminal and our negative coterminal are done. Number 3 is 75 degrees on the positive side and negative 285 degrees on the clockwise side or the negative side. Okay. Number 4, 570 degrees. Okay, so we've got another larger than 1 full revolution. So let's do the same thing we did for number 3. Let's subtract 360 instead of adding right away, right? Because that's going to keep me in positive numbers. 210 degrees is my positive coterminal angle. Now, we don't really have to go back to 570. I can go from the 210 and subtract 360 from that. Because again, they're all going to be coterminal to each other. Anyway, so when I do that, I'm going to get negative 150 degrees, which is going to give me my negative coterminal. So number 4, 210 degrees and negative 150 degrees. Okay. Number 5, and that will be the last one in the degree set. And as I'm doing this, let's talk a little bit about positive and negative angles. This is 75 degrees. Remember something about a negative angle in terms of the negativity of it? It's not actually negative. It just represents the other direction. Okay. So positive angles represent a counterclockwise rotation around the unit circle. Negative angles aren't necessarily negative. They're still the same measurement of that angle. It just represents the other way. So don't think of it in terms of like, you know, profit versus loss, you know, money, I'm getting money versus debt, like I have to owe somebody. It's not really like that. It's just the negative indicates that it's just going the other way. Okay, so they're still the same values. They're just, one's going clockwise, one's going counter. So with my 75 degrees, I am going to have to add 360 to it to get a positive coterminal, and that's going to be 435 degrees. And then with my 75 degrees, I'm going to subtract 360, which is 1 revolution the other way, and that is going to give me negative 285. Wow, 2 negative 285s? That's weird. That's strange. So 435 degrees and negative 285 degrees. I can't really gauge because the window, actually the glass actually goes further that way. So sometimes it's hard to gauge. All right, number 6 is where things change a little bit, right? So number 6, don't worry, we're in this together. I've got negative 221 pi over 90. Sorry, I just threw up my mouth a little bit. Okay. Wow, this is a mess. I don't know what that is on the unit circle. It's not actually on the unit circle because it's not one of those major measurements, but I know it's not something that I've ever seen before. I've never seen this number before in my life. Well, what does it mean? Well, let's try to understand, right? It's a negative angle, which means it went clockwise. It certainly appears to be much bigger than 1 full revolution. Not that much bigger, and I know that because of how this works, right? Let's not worry about how it works just yet. Let's just try to find the answer. Let's try to find a positive coterminal angle first. Well, if I want to find a positive coterminal angle, think what we did in the past. We just added 1 full revolution to all those things to get what we wanted. We're not changing that process here. But because I'm in radian measurement, I have to add 1 full revolution in radians. So I'm going to add 2 pi to this, which is 1 full revolution of conversion from degrees to radians, because 2 pi is 1 full revolution. Problem is that I can't just add 2 pi to this. We don't add fractions like that. We need a common denominator. So I'm going to put 1 underneath that 2 pi. Now again, I don't have my common denominator, so we're going to make it a common denominator. I'm going to multiply by 90 on top and bottom. Because when I add a full revolution to this original coterminal measurement, I need it in terms of whatever the denominator comes with it, right? So I need to make this a 90 in order to figure this out. So what does this really say? It says negative 221 pi over 90 plus 180 pi over 90. I know this looks weird, this fraction. This is simply one full revolution in terms of the denominator. So let's add them across and see what we get. I have a negative 41 pi over 90. Now, we would need to do this again to get a positive coterminal. But look at what we ended up doing, kind of like matter-of-factly, coincidentally. I ended up getting another negative coterminal. So negative 41 pi over 90 is the negative coterminal angle I'm looking for from the OG coterminal, negative 221 pi over 90. So my negative angle is this. So it's negative 41 pi over 90. Now, I want to add another full revolution to this in order to go into the positive realm, right? Because negative 41, I can just add one more revolution. So we're going to add 180 pi over 90 to that, right? And then that's going to give me 139 pi over 90. That is my coterminal positive angle. So 139 pi over 90 represents the positive. So again, we're going to have 4 more problems like this. I'm still adding one full revolution. It's just different on what it will look like, right? In terms of this one, that is one full revolution, 180 pi over 90, right? To number 6, okay? Now again, how come I just don't add the 2 pi straight up? Well, I can't because it's not in the same terminology. It doesn't live in the same world as that 90 underneath, right? So, that was 6. So number 7 is pi over 18. Okay, well, pi over 18 is definitely within, at least it appears to be within one revolution. Now that's not really super important for us now because we're not graphing it. But again, I want to make a positive coterminal or the next positive coterminal and a negative. So again, I'm going to be adding one full revolution to that. That's one full revolution, but it's not in the same terms. I need to make it into the same terms by putting 1 under the denominator and multiplying by 18. Because now, once I calculate this out, it will be in that terms. So this is going to be pi over 18 plus 2 pi times 18 is 36 pi over 18. Now I can add them because this is one full revolution more than the original in terms that I can actually add. So this is going to be 37 pi over 18. And that is my coterminal positive angle. So we got a 37 pi. Hello. How are you? Now, I'm going in the other direction. So let's go back to our pi over 18. And now let's subtract one full revolution. 36 pi over 18. So when I subtract them out, I'm going to get negative 35 pi over 18. All right? So that would be my negative coterminal. Moving on. Let's go to number, that looks white. Doesn't that look white? That doesn't look as pink as the other ones. That's weird. Isn't that weird? Huh? I can't hear you. That's funny. This is a one-way. Yeah, okay. Stupid. Should I edit that? I don't think so. It wasn't that bad. It was just a bad joke. Okay, negative 5 pi over 12, right? All right, it's negative, and it's certainly within the realm of one revolution. So let's add 2 pi, one revolution, and see what we get, right? So we'll do over 1, we'll multiply by 12. So this is going to be negative 5 pi over 12 plus 24 pi over 12. This will give me a 19 pi over 12. That is the positive coterminal, right? So we'll do 8 as 19 pi over 12. That's the positive version. Now, I'm getting more positive, right? So let's subtract one full revolution from that. So negative 5 pi over 12 minus 24 pi over 12. And that's going to give me negative 29 pi over 12. So that's my negative version, negative 29 pi over 12. That's a negative sign, okay? Again, it looks white. Did I move this? It's strange. Okay, 2 more problems in this set, and then we'll move on to another type set. Number 9. I've got 7 pi over 3. Okay, so let's add 2 pi, 1 revolution. It's over 1. Multiply by 3, multiply by 3. So this is 7 pi over 3 plus 6 pi over 3. I think you're seeing the pattern here, how I'm making this work, right? So we're going to get 13 pi over 3. That is one possible coterminal positive. I could have actually subtracted, and it would have still been positive, which is totally fine. Either answer is fine, right? So this would have been just pi over 3, right? So both work. I'll put the first one I had, though, 13 pi over 3. And then we'll subtract one more from our pi over 3, one more revolution. So we'll subtract 6 pi over 3 here, and I'm going to get negative 5 pi over 3. All right? Hopefully you're getting the hang of it. And if not, watch it again. Right? I don't know why you wouldn't want to. I don't know. I watch my videos all the time. 37 pi. 37 pi over 30. Okay, messy. Certainly feels like one bigger than 1 revolution, but that's not really super relevant. Let's add, right? So let's add 2 pi. So over 1. Multiply by 30 on top and bottom. We're gonna get some big numbers here, but that's okay, right? 37 pi over 30 plus 60 pi over 30. That's gonna give me a 97 pi over 30. That could be my positive coterminal. We'll subtract it and we'll get what you might have seen on like a sheet of paper as an answer key. So if we do 37 pi over 30, subtract or minus 60 pi over 30. Oh no, that'll give me what I'm looking for. 97 pi over 30 is what I want. That's not 1 revolution. That looked like 1 full revolution at least. See how that's weird? And I'm gonna get a negative 23 pi over 30, which is the negative version of that, okay? Let's see if this looks white like last time. Do they still look whiter? A little bit. They look lighter, whiter, brighter, you know? Negative 23 pi. See, I'm not even looking what I'm looking. 30. Yeah. The light's right there. Okay, whatever. All right, so there's our set, right? Positive and negative coterminal angles. Let's move on. Okay, so that was set through 10. I'll erase after I go to 11 here. Number 11 is the same set for coterminal angles, but it's going to be a little different. This part, or this portion, is asking for a coterminal angle between 0 degrees and 360 degrees. So we need something between 0 and 360. So we need to have theta, or our degree measurement, greater than 0 but less than 360. Now, what's interesting about this is I can't... Oh, how interesting. Did you find this interesting too? Hey, what are you doing? I heard something. Very strange. Strange dog. It can't be 0 degrees and it can't be 360. You see how we have less than signs here, but it means, you know, the theta is greater. It has to be bigger than 0 and less than 360. It can't be greater than or equal to, right? I don't have equal to signs. So that's interesting. You just be careful of that. All right, so I've got a 390 degree angle here. Well, it's already outside of the boundaries that I set. So what do I need to do to make the coterminal angle in the boundaries? I'm going to subtract. And I'm going to subtract 1 revolution. So 30 degrees is my answer, right? So number 11 is 30 degrees. Again, I need to work within the constriction here of the 0 to 360. And you will see this very often when we come to coterminals, right? So number 11 is going to be 30 degrees. Okay, I'll keep that up there. Remind me not to erase it. Thanks. Number 12. Hey buddy, what are you doing? 420 degrees. Again, certainly greater than the boundary of 360. Again, I'm going to subtract 360. All right, and that's going to give me a 60 degree angle. So 60 degrees is number 12. This section will go a lot faster, as you can imagine. Number 13, because this is easy. 13 is 435 degrees. They were all bigger than 1 revolution, really. Okay, whatever. Minus 360. This is like silly. 75 degrees. Okay, so again, I needed to be somewhere within the boundary of 0 to 360. Those are my boundary points. I had to just subtract each one. Now, if I had a negative angle, I would be adding 360 to it, right? Okay. Now, the next 3 problems are the same idea, but I'm going to change something for you. But what really changed, right? I'm still trying to get an angle that's coterminal to what I'm giving you, but now it's synonymous, right? Instead of 360, now it's 2 pi. But that should be a giveaway to say, I'm giving you the angle in radian measurement instead of degree measurement, right? So let's take a look at number 14. Number 14 is negative 9 pi over 4. All right, so now we can piece some things together. I need the coterminal angle to be between 0 and 2 pi, right? 1 full revolution of my circle. Well, this is certainly not within that boundary because this is negative, meaning it is not between 0 and 2 pi. So I'm going to do exactly the same thing as I did before. Because this is a negative, I have to add a full revolution to this. But because it's in radians, I need to keep it in radians. I got to keep everything together in the same unit, right? So I'm adding 2 pi, but I have to get in terms of that denominator specifically. So then I've got negative 9 pi over 4 plus 8 pi over 4, right? And that is going to give me negative pi over 4. Problem, right? I'm still in negative territory. I need it to be a positive angle, but less than 2 pi. So guess what? We have to do that again. We're going to add 8 pi over 4 again, and that's going to give us 7 pi over 4, which is certainly within the boundary of 2 pi. Now, how do I know, or how do we know? Well, if 8 pi over 4 represented 1 full revolution, 2 pi, because it is, 7 pi over 4 is less than that. So I know that I'm doing the right thing. 7 pi over 4 is my answer because that falls within the boundary line and it is less than 2 pi. Okay? Let's do 15. Okay, 15 is negative pi over 3. Negative angle. This is not a very large degree measurement or a large radian measurement, so I should be able to get away with just one addition of my 2 pi. So I'm going to add 2 pi, same deal as everything we've done before. I have to convert it so it's in terms of the denominator. This is negative pi over 3 plus 6 pi over 3, which is going to give me 5 pi over 3. And again, 6 pi over 3 is 2 pi. It's just written in a different format. It's the same value. And 5 pi is less than 6 pi, right? So I know I'm right. So number 15 is 5 pi over 3, okay? Last one in this set, and we'll move on to something else. Something even easier. Number 16. See, the funny thing is this isn't really easy. It's just, once you get the hang of it, and once you understand what is actually happening here, because you might not really be understanding what's happening, but you understand the process. That's the first step to full understanding. You understand the process, you understand what to do. Then the development of what is actually happening here comes along. That's kind of the MO of pre-calculus, unfortunately, right? First, try to understand what is needed to be done, and then we can go from there. Okay, 77 pi over 36. Wow, that's weird, right? That appears to be bigger than 1 full revolution. A trick that you could figure out is, if the numerator number or the numerator coefficient is more than double the denominator, we're looking like it's more than 2 pi, right? 36 times 2 is 72, less than 77. So that extra little 5 that's up here typically is looking at that we're over 1 full revolution. So let's subtract, because again, I need it to be within this boundary. Let's subtract 2 pi and see what we get, right? So 2 pi over 1, I need it in terms of 36. And we're going to get what we just talked about, right? 72 pi over 36. Now I'm going to get 5 pi over 36, which is within the boundary of my 0 to 2 pi. My answer for number 16 is 5 pi over 36. Smooth. Okay, next set of problems, because I think we're done with coterminal for the time being. Degree and radian conversions. Whew, I think I need another marker for this one. Let's go blue. Oh, blue's almost out. Don't be out. I want to use more of this blue. Let's see how much we can get from it. All right, number 17. So number 17, see how nice? Okay. Degree to radian conversions, we'll go through the process. The first 2 problems, there's not many of these because they're too easy. Negative 225 degrees. Okay, well, I'm giving you degrees, which means I'm looking for a radian conversion. When I give you degrees, we are going to multiply by pi over 180. because we are trying to introduce pi into our final answer or our simplification of this. When we're trying to introduce it, pi goes on top. When I do this, I get negative 225 pi over 180. Now, this is usually the part where we don't have calculators, right? So we have to simplify this by hand, which stinky. So what do both of these numbers have in common that I know have in common? Well, if we have any kind of understanding of the unit circle, which you should have a decent understanding of it, both of these numbers are actually degree measurements on the unit circle, and they are in 45-degree increments, right? So if I divide 45 on top and bottom, I'm going to get actually what I want, right? So 225 divided by 4 is going to give me my 5 value, so negative 5 pi, and 180 divided by 4 is 4. This is actually my answer. Now, if you weren't, or you didn't see that, you could have easily divided both by 5. Yeah, you're probably going to have to do some long division if you don't have a calculator, but there's worse numbers to divide, right? So number 17, my conversion measurement is negative 5 pi over 4. Okay. Number 18 is going to be another degree measurement, which is obviously going to be changed to a radian. So number 18, 410 degrees. Okay. It actually doesn't matter. So this is one of those things where it doesn't matter what the degree measurement is. If it's way bigger than 1 revolution or way less, who cares? I'm still converting it, right? So again, degrees to radians is pi over 180. So this is 410 pi over 180. Okay, well, 410 is not really a number that we use often. So I know I can divide both by 10, right? Because they both have a 0 on the back. So this is 41 pi over 18. Well, 41 is prime. I can't divide any number into 41 except for 1 and 41. So this is actually my answer. The answer to number 18 is 41 pi over 18. Okay. Next two problems are going to be radian driven, radian to degrees. Okay. Number 19, 3 pi over 4. You should be able to tell me that off the top of your head if you're good with the unit circle, but we're going to convert it anyway, right? So when I want a radian to degree, I'm going to be multiplying by 180 over pi. And the reason we do that is because we're trying to get pi out of the equation or get pi out of the expression. So we will divide by pi because the pi's will cancel, right? So pi and pi cancels. Now I like to cross cancel here rather than multiply across, because what's going to happen is you're going to get really big numbers that are going to be harder to simplify as fractions. So 180 over 4, that's conversion you should know, again, because it's unit circle driven. If I divide both of those things, it's going to, or simplify, it's going to be 45 over 1, right? Because 180 divides 4 45 times. So now I've got 3 times 45 over 1, or just 3 times 45. That was a snap. That didn't sound good. This is 135 degrees. Hey, Titan, you okay, buddy? Come here, buddy. The world wants to see you. They haven't actually seen you yet. He's here. He just moved in. Number 20. Hey, buddy. Can you come over here? This is your channel, pal. Come here. No, he's not. He doesn't want to do that. And if you know anything about Titan, which you don't. Oh, hey. Hi. You don't want to annoy Titan because he will come back at you. He will get you. He remembers. Hey. Okay. So this is going to be 180 over 3, which is 60. Ow. Ow, don't step on my foot, stupid. 60 over 1. So this is 200. Stop that. Stop stepping on my foot, stupid. You're stupid. Okay, 240 degrees. Number 20. Hi, I know. And, oh, you want to lick my hand? If you lick it up here, if you lick my hand right here, they'll see you. No. Come here, buddy. What did I put? 20 is 240. I know you're not interested in the dog. You're like, come on, just keep going. This is an hour-long video. I don't think it's going to be an hour, though. I think it's less. Okay, let's move on. Reference angles, because degrees and radians are too easy. All right, number 21. Reference angles. Okay, reference angles have to be two things. They have to be positive and they have to be acute. The other thing that is super important with reference angles is if you know that it's always in reference to the x-axis or 180 degrees, you're in great shape. So, number 21, we want to find the reference angle. Now, it's giving us a graph. I won't graph all of these, but I'm going to just show the first two as a graph. So the problem is showing me this. This is a 100-degree angle, right? Certainly it's positive, it's going counterclockwise. Now, we want to know what the reference angle is. Remember what I said, reference angles have to be two things. One, positive, and two, acute. And 180, the x-axis, is the reference point. So I'm looking for this angle. I want to know what that is. Well, if I know the straight line is 180, 180 minus 100 is 80. So 21 is 80 degrees. Certainly positive, certainly acute. I'll show you one more like that, and then I'll just go ahead and get the reference angles. Number 22. This is actually a good one I'm showing you. Number 22. Okay, it looks like this, but that's not what it's supposed to be. It's this. That little circle, I don't know what the left part of that was. And I don't know why this is crooked. Just look at it like this. Okay, this is a 330-degree angle. Okay, and it's 330 because it opens all the way around. So that circle indicates that the angle is actually this whole thing. Now, my nose is itchy. I think it was Titan. I think he licked my hand and then I touched my nose. It's stupid. So if I have a 330-degree angle, again, I'm looking for the leftover part, or what gets me back to the x-axis. It always has to be positive and it always has to be acute. So the difference between what I have here and this x-axis is 30. So number 22 is 30 degrees. Okay? Not negative 30. It can't be negative. Reference angles are never negative. They're always positive. Okay. 23. Okay, I have a negative 310-degree angle. Okay, well, negative 310 degrees is just going to be clockwise around. So where it ends is obviously going to leave me with an acute angle. Well, if we're looking at 180, we can also look at it when it's over or close to 360 as 360. So what's the difference between that 360 and 310? Well, it's 50, and 50 is my answer. Now, because 180 is a good reference point, I can simply add 180 twice, which is 360, which leaves me with 50 degrees, right? So if we have an angle that's really close to 360 degrees, we can just add 360 because that is a multiple of 180, right? Moving on. Now, if you want to draw these things, you certainly can. That will help. But again, in the interest of time, I'm not going to do that. Okay, let's say I have a 300-degree angle. Same idea as before. Let's subtract the 180 a couple times, and when I do that, I'm going to get 60. 60 degrees is my final answer. Okay, because 300 degrees is counterclockwise. If I subtract 180, right, I got 120. And if I subtract 180 again, because 120 is not acute, I'll get negative 60. But again, it's irregardless of the sign. The sign doesn't matter because the sign just represents direction. 60 degrees is my answer because it can't be negative, right? I'm just trying to get to something that's less than 90 degrees. As soon as I get to that something that's less than 90 degrees, I know I'm good, all right? So 60 degrees is my answer for that problem. Okay, 25, 245 degrees, okay? Well, 245 degrees is not close to 360, but it's certainly more than 180. Well, if it's more than 180 and it's not exactly 360, I can just subtract out my 180s, which leaves me with 65 degrees, which is the answer. 65 degrees is the reference angle for that. Okay, 26. And now 26 begins the process of radian measurement. 16 pi over 9. This is where it gets a little more complicated, especially when you don't have a graph. Well, 16 pi over 9 is really close to what number? 18 pi over 9. And 18 pi over 9 is going to represent my 2 pi, my full revolution, one full revolution. Now, because it's a 16, really close to 18, which is that one full revolution, I need to find what's going to make up the difference to get from 16 to 18. Now, the reason why this is going to work is because I need it in terms of either 2 pi or 1 pi. Again, 180 degrees or 360 degrees. So this is almost one full revolution. Because of that, there's only a little sliver left of the coordinate plane or the unit circle that I need to make up. So the reference angle here is going to be the difference between 16 pi and 19 pi. So what plus 16 pi over 9 gives me 18 pi over 9? And the answer is 2 pi over 9. Okay, that is actually my answer for number 26. Now, again, this works because 16 is really close to that 18 pi over 9. Again, that 2 pi conversion. You're going to see a couple more in here that won't work to the 2 pi. But again, this is a big angle, or almost a full revolution. So when we have smaller revolutions, meaning half angle revolutions or half or pi revolutions, you're going to see a little bit more what we're talking about. So let's take a look at number 27. 27 is exactly what we're talking about. Negative 11 pi over 9. Okay, now, negative 11 pi over 9. Well, let's think again in terms of my denominator. 18 pi over 9 is 1 full revolution, or in this case, negative 18 pi over 9 is 1 full revolution. Because I'm not really close to 18 pi over 9, I just need to get to 9 pi over 9, because 9 pi over 9 is 180 degrees, because it's just going to simplify to pi. So what number is going to get me to that 9 pi over 9? And that is going to be 2 pi over 9. Now again, it's not negative, it's just the direction. So regardless of the sign, what number can I get 9 pi over 9? And that's a 2. So my answer for number 27, the reference angle, is 2 pi over 9. That's so weird, they're the same exact answer. Oh, because they were in terms of 9s. That's weird. I feel like that's the second time this happened today. 28. I'm not doing 28 like that because it's exactly the same problem almost. Number 28, I can't make this up. Negative 16 pi over 9. Same as 26, but this is negative. Same distance. Like, I'm trying to get to 18 pi over 9 because 18 pi over 9 is that multiple of, 180 twice. So my answer here is, again, 2 pi over 9. That's 3 2 pi over 9s in a row. I feel like you did this. Titan, where are you? It's scary. It's when you don't hear them for a while that things get bad. Okay, 4 pi over 3. Okay, again, a measurement on the unit circle that you probably should know the degree measurement of. Now, 4 pi over 3 is certainly not 1 full revolution. It's in quadrant 3, so it's less than 270. So 4 pi over 3, I'm trying to get to 3 pi over 3, because 3 pi over 3 is 180 degrees. So what value gets me to 3 pi over 3 regardless of the sign? And that's going to be 1 pi over 3, or just pi over 3, right? Because if I subtracted them, I'd get there. But again, reference angles aren't negative. They're just the positive version of that. So I know that that's weird, because when you add it, it's 5. I am subtracting it, but subtracting it just means I'm going the other way, right? So this is 29, and this is pi over 3, okay? Number 30 is the last in the set, and then we'll move something else. And number 30 is 14 pi over 9. A lot of 9s in this thing. I don't know why it's like that. It's not usually like that. Okay, 14 pi over 9. Again, that's really close to our 2 pi measurement of 18 pi over 9. So what do I have to add or subtract to the 14 pi to get to 18? My answer is 4 pi over 9. Again, regardless of sign. So number 30 is 4 pi over 9. All right, 20 to go. All right, next set of problems. Find exact values. Oh, people hate this, including me. Finding exact values of trigonometric functions requires a pretty healthy knowledge of the unit circle, right? And also a pretty healthy knowledge of our ratios. So, because we're gonna have all 6 ratios represented here, or all 6 trig functions, I'm gonna put to the side those measurements. Oh, yellow. Okay, so that was 30, so this is 31. Okay, off to the side here are our ratios. So cosine is x and sine is y, but we'll just say cosine. We can just put x and y, it's fine. There's no reciprocal values here, so it's just those 2 things. Tangent is sine over cosine. Yes, it's opposite over adjacent, but we're not using right triangles here. We're just trying to find the measurements of the unit circle. Cotangent is cosine over sine, or x over y. Sine's inverse is cosecant, so that's 1 over y, or 1 over sine. And cosine's inverse is secant, which is 1 over cosine. Okay, so I'll leave that there so it helps us out remember our values, and let's get started. Number 31, I'm looking for sine of 30 degrees. Now remember, when I'm looking for exact trigonometric values, I am actually looking for that ordered pair or that part of the ordered pair on the unit circle. Especially when it comes to sine and cosine, because they're just the regular values. Remember, sine values are y values. So this question is asking us, what is the y value at 30 degrees? And if you know your unit circle, the y value of 30 degrees is 1/2. So, excuse me, number 31 is 1/2. Again, cosine, sine should not be terribly difficult. Number 2. Sorry, 32. This is a different sheet. 32, we jump into something really crappy. Cotangent of 120 degrees. Okay, now, cotangent of 120 degrees. First, I need to know what 120 degrees is. Like, what is that actual ordered pair? So 120 degrees on the unit circle is negative 1/2, comma, root 3 over 2. Okay, x, y. Well, cotangent is cosine divided by sine, or x divided by y. So I'm actually going to divide these things. Negative 1/2 divided by root 3 over 2. And the reason I'm doing that order again is because cotangent is cosine divided by sine, x divided by y, x divided by y. Now, I don't like to divide these things like this because it's a mess. I actually will do this old school, and I will multiply by the reciprocal, which is what we do in fractions. All right, well, that looks a little better. The 2's will cancel, and I'm going to be left with negative 1 over the square root of 3. Well, we can't leave the square root of 3 in the denominator, so we rationalize. This is going to happen often, unfortunately. I'm going to have negative root 3 over 3, which is my final answer. Cotangent at 120 degrees is negative root 3 over 3. Again, a pretty healthy knowledge of the unit circle makes this a lot easier for you. See, the great thing about yellow is it's very bright. The bad thing about yellow is it's difficult to erase. I know. Pros and cons. 33. Tangent of 45, that should be relatively easy. All 45-degree measurements on the unit circle must be a root 2 over 2, root 2 over 2 combination. Now, 45 degrees is positive, right? So the actual ordered pair here is root 2 over 2, comma, root 2 over 2. Tangent is sine divided by cosine, or y divided by x. I'm not going to divide it out for you because anything divided by itself is 1. So number 33 is 1. Right? Someone said no out there. A car is speeding away. Titan, did you take the keys again? Hope not. 34. Cosine of 0. Really? Whatever. All right, well, what's the x value at the 0 degree mark? It's 1. Because the unit circle has a radius of 1. I should have changed that. Sorry. 35. I hope you're lucky and get that on a quiz or test. That'd be awesome. Okay, secant of 30 degrees. All right, well, just like the other 3, I guess, advanced trig functions, if you want to call it that, I want to find out what the ordered pair is at 30 degrees. Or, in this case, I just need to know what the cosine value is at 30 degrees. Because secant and cosine are inverses of each other. So, if I know what the cosine value is at 30, I'm looking good. So, the cosine value at 30 degrees is root 3 over 2. Another one of those root 3 over 2 deals. Now, secant is 1 over cosine. So then this is going to be 1 divided by root 3 over 2. So we have another duplicate fraction type thing. So 1 divided by root 3 over 2. Again, let's do this sideways. This is going to be 1 times the reciprocal, 2 over root 3, or just 2 over root 3. But I'm rationalizing the denominator. So that's going to be 2 root 3 over 3. So number 35 is 2 root 3 over 3. Okay? That's a stinky one. Again, the 3 advanced functions, secant, cotangent, and cosecant, they require a little bit more work. And if you are unlucky to get a radical, you're going to have to rationalize denominators and go from there, right? 36 is cosine of 3 pi over 2. I'm trying not to give away how easy this is. Well, the 3 pi over 2 value, my cosine value is 0. Because 3 pi over 2 is my 270-degree angle, which is straight down, right? So 0 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2. The x value at this is 0. So 36 is 0. Okay. If I asked for the sine value, there'd be 1. That's why I was writing 1, because in my head I thought it was sine, because I don't know how to read, which makes reading difficult. 37. Cosine, okay, now we're getting to some beef. Cosine negative 3 pi over 4. Okay, well, what is negative 3 pi over 4? It's certainly not 3 pi over 4, right? So negative 3 pi over 4 just means I'm going the opposite way on the unit circle. So if you know where 3 pi over 4 is, it's in quadrant 2. I'm just going the other way. Now, there's a denominator of 4 here, which should be a giveaway. 3 pi over 4 needs to be some ordered pair that has a root 2 over 2 and a root 2 over 2. All 4 denominators have to be that. So if it was 3 pi over 4, it would be negative root 2 over 2, root 2 over 2. But the negative 3 pi over 4 puts me in quadrant 3, which means it's a negative negative, right? Because they're both cosine and sine are negative at that point. So the cosine value at negative 3 pi over 4 is going to be, I don't have to write it up there because I don't have to do anything about it, negative root 2 over 2. Okay? Again, the 4 denominators are really easy to remember because they're always root 2 over 2. Doesn't matter where they are, it's always going to be some value, some kind of root 2 over 2, whether it's positive or negative. 38. Tan of 7 pi over 6. Well, 7 pi over 6 is actually a value on the unit circle, right? So tangent is sine over cosine. Well, first, we want to know what the value is, or the ordered pair at 7 pi over 6. And that is going to be negative root 3 over 2, comma, negative 1/2. Again, because tangent is going to give me that quadrant 3 value. So they're both negative values. And tangent is sine divided by cosine. So I've got a negative 1/2 divided by negative root 3 over 2. Or negative 1/2 times negative 2 over root 3. We've actually done one like this before. Both 2's cancel, and I've got a negative times a negative, which is going to give me a positive value. Remember, the tangent is always positive in quadrant 3 also, so that maybe would be a little bit of help. So I'm going to have a 1 over the square root of 3. Rationalizing the denominator gives me a root 3 over 3, which is my final answer. I thought I had more space there. I did not. Okay. 2 more in this set, and we'll move on to something worse. It's actually not that bad. It's not. It might be. Okay. A race better. 39, we're almost there. 39 is cosine 3 pi over 4. Again, another value on the unit circle. So cosine of 3 pi over 4, again, we've got a 4 denominator. So 0 pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 3 pi over 4. Cosine values are negative in quadrant 2. So my value here is going to be a negative root 2 over 2. I want a space. Negative root 2 over 2. And again, a 4 denominator must be some kind of root 2 over 2. Okay. 40, last number in the set. Make it a hard one. Cotangent 3 pi over 4. Well, that kind of sucks. We just did a 3 pi over 4. All right. Well, cotangent again is cosine divided by sine. Cotangent of 3 pi over 4. Well, what is the value at 3 pi over 4? Or what is the ordered pair at 3 pi over 4? Well, it's a negative cosine value and a positive sine value. So I'm going to be dividing. I don't know why that 2 is so different than the other 3. I made like 4 different types of 2s here. You see that? That one has a curl. That one looks like a Z. That one looks like a better Z. And that, I don't know what that is. It's like a wisp. It's like a wisp of air. Cotangent is cosine divided by sine. Well, anything divided by itself is 1. And there's a negative in part of that. So my answer is negative 1. A wisp. Cool. 10 more problems. Whew, this one flew by. I'm going to keep that up there because we're probably going to need it. All right, last set. Given one angle or given theta, can you find all of the other or remaining trig functions? The answer to that is yes. Hopefully. I'll keep yellow, even though it sucks to erase. Okay. 41. Okay. theta, let's say theta is 5 pi over 4. Find the exact values for cosine, sine, tangent, secant, cosecant, and cotangent. That stinks. I don't want to. I know you probably don't want to. Here's what we do. If it doesn't specify what value I'm looking for, that means I just need to find out what the ordered pair is at 5 pi over 4. Right? So 5 pi over 4 is a value on the unit circle. 5 pi over 4 is 225 degrees, which is going to give me both negative root 2's over 2. So we have a negative root 2 over 2 and a negative root 2 over 2. So there's that wisp again. Okay, at least I didn't do any curls. I need every value on the unit circle here. So these are going to be longer problems, right? Number 41. Cosine is negative root 2 over 2. Sine is negative root 2 over 2. Tangent is 1, because I'm dividing. That means that cotangent is also 1, because tangent and cotangent are inverses of each other. 1 over 1 is 1 over 1. Secant is 1 over cosine. So 1 over root 2, negative root 2 over 2, which is 1 times negative 2 over root 2, okay? Which is going to be root 2 and root 2. This is negative 2 root 2 over 2, which is negative root 2. So secant at this value is negative root 2, okay? A very odd number, but it certainly is there. So if cosine and secant are the inverses at the same exact value, and sine and cosecant are also the same, I'm going to have the same exact cosecant value, right? So that's how this kind of works out a little bit, right? So that wasn't too bad. So again, you need to know your 6 ratios. Obviously, cosine and sine and tangent you should know by now, but the other 3 you should know as well in terms of getting better at it. And then we're trying to find the values at this thing. Let's do another one. We actually have a couple more like this, so let's power through. I'm probably going to be able to keep 2 up at a time before I have to erase them. Ooh, this is rough. I just cleaned this board too. Maybe that's why. It's like sticky. You can see that, right? Go away. Okay. 42. Given theta is 7 pi over 6, find all trig values. Well, we want to know what 7 pi over 6 is. Well, 7 pi over 6 is 210 degrees, and the ordered pair is negative root 3 over 2 and negative 1/2. So we're still in quadrant 3. This one's going to be a little different because we can't just keep our values. Cosine, negative root 3 over 2. Sine, negative 1/2. Tangent, sine divided by cosine. So I'm just going to shortcut this. This is negative 1/2 times the reciprocal of cosine, right? Because I'm just flipping it. 2 and 2 cancels out. It's going to be a positive value. This is 1 over root 3. Again, I am rationalizing the denominator. I'm going to get root 3 over 3. So tangent is the square root of 3 over 3. Now, cotangent, I don't have to go through that whole process. And the reason for that is because if tangent is sine over cosine and cotangent is exactly the reverse as tangent, right? The other way around, I'll do it the long way, but I could just flip this around and rationalize the denominator, right? So it's the exact same process. It's going to look a little different because I have to rationalize. So cosine divided by sine is negative root 3 over 2 divided by negative 1/2 or times negative 2 over 1. The 2's cancel and I get root 3. That's going to be my answer for cotangent, just root 3. Because this is negative times negative, which is positive, and root 3 over 1 just becomes root 3. Okay? I almost was done. I thought I was done. Secant, you can barely see that. Okay, secant is 1 over cosine. All right, so 1 over cosine is going to be 1 divided by negative root 3 over 2, or 1 times negative 2 over root 3. Rationalizing the denominator gives me a negative root 3 over root 3. This is negative 2 root 3 over 3, right? Not the negative, just rationalizing. So negative 2 root 3 over 3, okay? And then the last one will be cosecant. And again, it's just going to be the flipped over part of that. So we don't have to keep doing this. We can just flip this over. If we have to rationalize, we have to rationalize though. So cosecant is going to be 1 over sine. So the 1 over the sine value is 1 divided by -1/2 or times -2/1, which is just -2. Okay, looking good. Okay, so you can see that right. Okay, 42. Whew. Rough, 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 rough. That's what doggies sound like. All right. Ooh. 43. Given that theta is pi over 2. Oh, that's a good one. All right. Let's erase this. Why am I so happy about this one? Well, because pi over 2 is a really interesting value. Because we have a 0 involved. It's going to change the game a little bit. The ordered pair at pi over 2, or 90 degrees, is 0, 1. So let's find out what we've got. 43 cosine, 0. Sine, 1. Tangent is sine divided by cosine. 1 divided by 0 is undefined. There is no value at tangent at that point. Cotangent is just the reverse of that, or the opposite, and that's going to actually be 0. Cosine divided by sine is 0. Secant is 1 over cosine. Huh. Well, 1 over cosine is also undefined. And cosecant is 1 over sine, which is 1. Interesting. 44. Again, can't make this up. Theta is 3 pi over 2. And again, I'm laughing because 3 pi over 2 is another one of those pole values. The ordered pair at 3 pi over 2 is 0, -1, right? Because that's my 270 degree. It's going to be almost exactly the same as this. So number 44. Cosine is 0. Sine is -1. Tangent, sine divided by cosine, is undefined. Cotangent is 0. Secant, 1 divided by cosine, is undefined. And then cosecant is 1 divided by sine. That's -1, right? Because I got a -1 value. So very, very, very interesting. You know what? Instead of doing the one that's on here, let's make this a little interesting. I think you know where I'm going with this. Let's say 45 is, let's say theta is 0. So there's no angle there. Let's just say theta was 0. It just started at nothing, right? Let's see what we got. Look, I'm erasing and shaking the marker. Isn't it great? All right. So 45 cosine. Well, the ordered pair here is 1, 0. Cosine is 1. Sine is 0. Tangent is sine divided by cosine, which is 0. Cotangent is cosine divided by sine, which is undefined. Secant is 1 over cosine, which is 1. And cosecant is 1 over sine, which is undefined. So you see how the cotangent and cosecant kind of flip the values with tangent and secant, right? So undefined changes when our 0 is in a different spot, right? Very interesting. All right, next set, last set, 5 more problems. I'm going to give you one value for a trigonometric function with a fraction, and we're going to find the other 5 functions, right? So 48 or 46, sorry. Cosine of theta is 4 over 5. Find the other, ooh, that's ugly. Cosine of theta is 4 over 5. Sometimes I forget where I'm at. I feel like I got really dark in here. Does it look darker in here? I know it's already pretty dark in here, but okay. Find the other values. Okay, well, we can draw a triangle to make this easier for ourselves. Now, think about it like this. Cosine of theta is 4 over 5. Cosine's positive, which means it can either be in quadrant 1 or quadrant 4. I promise it's going to be in quadrant 1. It would normally say that, so I apologize. So here's my unit circle, or here's the coordinates. This is what the triangle looks like. You want to draw a triangle, it'll make your life a lot easier, right? Theta will always be closest to the center of that coordinate plane. So cosine, remember, is adjacent over opposite. So the adjacent side is 4, I'm sorry, adjacent over hypotenuse. and the hypotenuse is 5. Now, we don't know what the opposite side is because cosine is ka, right? Now, this is a Pythagorean triple. You should know that x is going to be 3 here, which makes my life a lot easier and your life way easier because now we can just use the trig functions to our advantage. Now, here, we're going to change these to the actual SOHCAHTOA type things, right? And that will be easier, and we want to change it because now we have actual values instead of radian measurements that we're trying to pull from, okay? Cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. Tangent is opposite over adjacent. Secant, the opposite of cosine, is hypotenuse over adjacent. Cosecant, the inverse of sine, is h over o, and cotangent is a over o. Now, that makes our life, again, very easy. So, number 46. Cosine was given, so we'll go right to sine. Well, sine is opposite over hypotenuse, so sine is 3 over 5. Let's go to tangent, because that's the next one in order normally. Tangent is opposite over adjacent, 3 over 4. Now, we don't even need to read the triangle. We can just flip these fractions over. So, the opposite of cosine is secant. If cosine is 4 over 5, secant is 5 over 4. Now again, secant is hypotenuse over adjacent, 5 over 4. It makes sense. The opposite of sine is cosecant, and cosecant is h over o. So h is hypotenuse, and o is this other leg, which is opposite. Brain stopped working. 5 over 3, and we know it has to be because it's the exact inverse of sine. And then cotangent, if tangent's 3 over 4, cotangent's 4 over 3. Done deal, right? 47. Okay. I only think there's 3 of these, and then there's 2 random problems on the end. Okay, sine is 8 over 17. Okay, so sine of theta is 8 over 17. Find the other trig functions. Now, sine is positive here, so sine can either be in quadrant 1 or quadrant 2, but again, it's going to always give you, on this paper at least, it won't always in real life, this is going to be in quadrant 1. So again, we would draw a right triangle on the backdrop of the coordinate plane, on the backdrop of a unit circle to help us out. So we have our right triangle here, and theta is here. Now, let's label what we know. We know sine is opposite over hypotenuse. So this is 8 over 17. We want to find x. So let's do that by using the Pythagorean theorem. X squared plus 8 squared equals 17 squared. X squared plus 64 equals, I want to say it's 289. Please tell me I'm right. Thank you. Again, brain stopped working. Okay, minus 64 on both sides. And I'm going to get x squared equals 225. Square rooting gives me x equals 15. So this is actually a Pythagorean triple as well. I did not know that. 15. Okay, well, now we know all our values. So 47, we know sine, so let's go back to cosine. Cosine is going to be adjacent over hypotenuse, so 15 over 17. We'll go to tangent, which is opposite over adjacent, so 8 over 15. And then let's go just strictly off of the ratios. If sine was 8 over 17, its opposite or inverse cosecant is 17 over 8. If cosine is 15 over 17, secant, its inverse, is 17 over 15. Hello, buddy. What are you doing? Doing something bad? Probably. If tan is 8 over 15, cotangent is 15 over 8. Done deal. Okay, let's do one more. We'll add a little spice to this one now. Hi. What are you doing? You're silly. I know. I know. Hey, come here. Look. They want to see you. Come here. Oh, he's like just out of reach because my hand goes here and his face is right here. It's okay, buddy. All right. Last one in this set. Okay. Given that cotangent, this is 46, 7, 8. Given that cotangent is 4 over 3, and cosecant of theta is greater than 0, find the other values. Okay, now what we have is we have a constraint. the constraint's going to help us identify where cotangent is, or where this triangle is on the unit circle. Let's think about this for a second. We know that all students take calculus, okay? Cotangent is 4 over 3. Cotangent is positive, which means its inverse, tangent, must also be positive. So that eliminates quadrant 2 and quadrant 4. It can't be there. So if tangent slash cotangent is positive, it's either in the all or it's in the tangent part. Now, let's go with the constraint and see where we go from there. It says that cosecant of theta is greater than 0, meaning cosecant is positive, meaning sine must also be positive. So sine is not positive in quadrant 3. Only tangent and cotangent are. So we are in quadrant 1. That was not done on purpose. It just was accidental that I picked one that was going to be in quadrant 1. But again, the constraint helps us figure out where it is. The initial part tells me where it could be, but the constraint finalizes where it's going to be, okay? So the original problem is going to say it's either in one or the other. So it narrows it down from 4 options to 2. But the second part will narrow it from 2 to 1. So let's draw our coordinate plane and our right triangle. Theta is 4 over 3. Now, cotangent is adjacent over opposite. So adjacent is 4 and opposite is 3, which means this is obviously a Pythagorean triple. The hypotenuse is 5. We've already done this type of problem, so I'll fly through it. I want the other 5 functions if I had cotangent. So let's just start with what tangent was. So this is 48. If cotangent is 4 over 3, tangent is 3 over 4. Let's go back to cosine. Adjacent over hypotenuse, 4 over 5. We've actually done this same exact problem with these same numbers, kind of. Sine is 3 over 5. Secant. Hypotenuse over adjacent, right? So 5 over 4. And we knew that because it was the opposite of cosine. And then cosecant, which is the opposite of sine, is 5 over 3. Okay? So, interestingly enough. All right. There's 2 more random problems. However, I think we've been going a little bit longer than I had originally planned for. So we're going to cut this a little short. I'll still give you the 50. Okay. Find the exact value of negative pi over 2. And we'll do sine. Okay. I want the exact value of sine of negative pi over 2. Well, I know that pi over 2 is 90 degrees, but negative pi over 2 puts me at 270 degrees. Remember, it's not negative, it's just the other way. So what is the y value at negative pi over 2? And that value is negative 1. So 49 is going to be a negative 1 value, okay? And then for the grand finale, number 50, I gotta come up with a good one. I'm probably not going to, because I'm tired. Okay, let's do this one. Let's convert 820 degrees to radians. That sounds like fun. So what I'm going to do here is I'm going to multiply by pi over 180 to get it to radians. This is going to be 820 pi over 180. Okay, now this is a mess, so let's just try it together. I know they have a 10 in common, so let's do that. Divide by 10 on top and bottom gives me 82 pi over 18. I know they have a 2 in common, so let's go to 41 pi over 9. 41 is prime, so I know that my final answer for number 50, our last problem, is 41 pi over 9. Whew. I'll tell you what, that was a marathon. I hope you got something out of it, though. Thanks for watching TitanClass. We'll see you next time.